Hi everyone, in this problem I want to look at how to find a binary tree of minimum height for a list of strings or words. All right, so first of all, let's talk about what is a binary tree. So the word binary has to do with two. So in a binary tree, we start off with a root, and each time we branch off at most 2 times. Okay, so here's an example of a binary tree. I know this individual over here only had 1, but that's okay. As long as we have at most 2, we are a binary tree. And in contrast, something that's not a binary tree, so we might have a root, and then we come down here and maybe we branched off 3 times. So this would not be a binary tree because we had 3 coming off instead of at most 2. All right, the next thing we want to talk about is what we mean by the height. So the height tells us how many layers down we had to go. So in this tree, I had to go down 2 layers, or I had to traverse 2 edges to get from the root to the leaf. Okay, and similarly over here, this would also be a tree, not a binary tree, but it's a tree of height 2. So I can put that down. And as one more example, let's do another binary tree. And I'm going to start here, and maybe I've got 1 individual off to the left, but then down to the right, you know, it's like, why would you ever do this to yourself? It's a really long tree. It's a very tall, or the height is very great. So let's calculate the height of this tree. On this side, there was only 1, but over here I had to go 1, 2, 3, 4, 5. So the height here is 5. You know, and so if you're looking at this tree of height 5, you're going to have to store a lot of stuff, and it's going to be quite cumbersome. So you might think to yourself, well, why did I ever store my data that way? Why don't I store it as a tree of minimum height? That's what we're going to do here. Okay, so if we're looking at a set of data, let's number our items just to see kind of how many things we have. 1, 2, 3, 4, 5, 6, 7 words. And I'm going to start numbering them in alphabetical order. So Berta would be first, Kathy is number 2, Darla is 3, Luis is 4, Manny is 5, Mike is 6, and Sandra is 7. In other words, Luis is the midpoint of our data. And that's when I'm going to choose as my root if I want to kind of balance my tree equally or roughly equally left and right. That's going to give me a shorter tree, hopefully. So I'm going to put Luis here, and I'm going to cross him off the list. So what comes before Luis? And again, I want to do this in some sort of balanced way. So if I put Kathy over here, and then after Kathy would be the number 3, which is Darla, and before Kathy would be the number 1, which was Berta. So I'm just really nicely balancing this. If I had put Darla here coming off of Luis, then I would start to get a long tendril down to the left, and I don't want to do that. I want to keep my tree very balanced as I go. All right, so similarly, when I come over to the other side off of Luis, and I'll just give myself a little bit of space here, you know, I could put Mike, Manny, or Sandra, but if I put Sandra here, then I'm going to have a long tendril coming down. So I really want to balance these words or these values. And so again, I'm going to kind of think about the midpoint here of the 5, 6, and 7. So it'd be the 6. So I'm going to put Mike here. And then before the Mike comes Manny, which was number 5 in my list. and then over here is going to be Sandra. So that took care of all the values. And I have a nice little balanced tree. The height here is 2 because no matter how I go down the tree, it's always just 2 trips down, and my height is 2. So this would be the height. This would be the minimum height for this data set. I can't get any shorter because it wouldn't be a binary tree, and I could get longer, but why would we want to do that?